For decades, air combat has been a high-stakes game of hide-and-seek. Stealth jets hiding, radar systems seeking. The F-22 Raptor is the reigning champion, engineered to be nearly invisible to conventional radar. Its faceted shape deflects radar waves away, like a mirror-bouncing light. The jet's skin is coated with advanced radar-absorbent material, soaking up radar energy and turning it into harmless heat. What little energy escapes is scattered by the F-22's angles, making its radar signature minuscule. To most radars, an F-22 looks no bigger than a marble. This stealth lets the F-22 spot and strike enemies before they even know it's there. Weapons are hidden inside the jet, not slung under the wings, to avoid radar reflections. Even the engine nozzles are shaped to hide from heat-seeking sensors. Every detail, from screws to seams, is designed to minimize detection. This is why the F-22 has dominated the skies for years. It was built to defeat traditional radar, giving the US a massive edge. But technology never stands still. New seekers are emerging, powered by the strange rules of quantum physics. The F-22's stealth is a masterpiece, but it was designed for yesterday's threats. As radar evolves, so must the art of hiding. The next chapter in this game is about to begin. The question, can the F-22 stay hidden from the next generation of seekers? The answer may lie in the bizarre world of quantum mechanics. The rules of the game are changing, and the F-22's greatest strength may soon be put to the ultimate test. Imagine radar that doesn't just bounce signals, but senses the very fabric of reality. That's the promise of quantum radar, built on the mind-bending phenomenon of quantum entanglement. When two photons are entangled, they're linked, no matter how far apart. Change one, and the other changes instantly. Quantum radar creates a pair of entangled photons. One stays at the radar station, the other is sent out. The traveling photon bounces off whatever's in the sky, clouds, birds, or a stealth jet. When it returns, the system compares it to its twin. Any change, no matter how tiny, is instantly detected. Unlike conventional radar, which shouts and listens for echoes, quantum radar looks for subtle changes in the quantum state. It's like having a fingerprint for every photon, making it nearly impossible to fool. This sensitivity allows quantum radar to spot even the faintest trace of a stealth aircraft. It filters out background noise with ease, focusing only on the unique signature of its entangled photons. The result? A radar that can see what was once invisible. Quantum radar isn't just a new tool, it's a new way of seeing. The game of hide-and-seek just got a lot more interesting. For stealth aircraft, the sky may never be the same. The age of true invisibility is under threat. For nearly a century, conventional radar has been the backbone of air defense. It works by sending out radio waves and listening for echoes, simple, reliable, and powerful. Over time, radar evolved. Doppler systems track speed, phased arrays track thousands of targets. But all conventional radars share a fatal flaw. They rely on detecting a reflected signal. Stealth aircraft like the F-22 are designed to minimize that reflection, making them nearly invisible. To compensate, radars crank up their power, but this turns them into beacons for enemy missiles. The more you try to see, the easier you are to find. Stealth jets can spot these powerful radars and avoid or destroy them before being detected. It's a dangerous paradox. To find stealth, you risk becoming a target yourself. This cat-and-mouse game has defined air combat for decades. Conventional radar is losing the battle against the physics of stealth. The F-22 was built to exploit this weakness. But as new technologies emerge, the old rules no longer apply. The next generation of seekers won't play by the same rules. The future of air defense is about to change, and stealth's greatest advantage may soon be history. Quantum radar rewrites the rules. It doesn't care about the strength of a reflected signal. It cares about information. When an entangled photon interacts with anything, its quantum state changes. That change is instantly mirrored in its twin back at the radar station. The radar isn't listening for echoes, it's detecting quantum disturbances. This makes it incredibly sensitive. Even the act of absorbing a photon gives away a stealth jet's position. Quantum radar can filter out background noise, focusing only on its unique entangled photons. Jamming is nearly impossible. A jammer would have to mimic the exact quantum state, which current technology can't do. Stealth design is all about reducing radar cross-section, but quantum radar doesn't care how much energy is reflected. Even absorbing energy is an interaction that quantum radar can detect. The very act of being stealthy could become a liability. Quantum radar sidesteps the core principles of stealth. The invisible may soon become visible. The game has changed. The US once held a near monopoly on stealth, but rivals like China are racing to break it. China has invested billions in quantum science, making it a national priority. In 2016, China claimed a working quantum radar prototype, reportedly detecting targets at 100 kilometers. Skepticism remains. Quantum systems are fragile, and real-world conditions are harsh. Yet China's progress is real. They launched the world's first quantum satellite, proving entanglement over 1,200 kilometers. Chinese media tout breakthroughs in quantum radar, communications, and computing. Their goal isn't just to match US stealth, it's to make it obsolete. If China fields quantum radars, the Pacific's balance of power could shift overnight. The invisible shield protecting US forces could vanish. The race to master quantum technology is on. Turning quantum radar from lab experiment to battlefield tool is a massive challenge. Quantum states are fragile. Environmental noise, weather, and movement can destroy them. Generating enough entangled photons and keeping them intact over distance is tough. Detectors must spot single photons and compare them instantly, often requiring complex cryogenic equipment. Building a rugged, reliable system is a huge engineering feat. Many experts doubt China's claims of a deployable quantum radar. But technology advances fast, and China is pouring resources into solving these problems. The question isn't if quantum radar will work in the field, it's when. If quantum radar becomes reality, it will upend military strategy. Stealth jets like the F-22 and F-35 are expensive because they can survive in hostile airspace. If they can be tracked, their value drops. They become just fast, costly fighters. Quantum radar would make them vulnerable to long-range missiles from the moment they take off. The hunter becomes the hunted. Air combat tactics would shift. Instead of relying on invisibility, militaries might deploy swarms of cheap drones to overwhelm defenses. Attrition and numbers could matter more than stealth. The implications go beyond the air. Naval and land assets would also lose their cloaks. The battlefield would become transparent. Victory would depend on who can process information and strike fastest. The age of hiding may give way to the age of speed and networks. The rules of war are changing. The future belongs to those who adapt first. Quantum radar is just the start of a new arms race. The US and China are both racing for quantum supremacy, not just in radar but in computing and communications. Whoever masters quantum tech first will hold a decisive edge. The US is investing heavily, developing its own quantum radars and exploring quantum stealth. The next step, hiding from quantum detection, perhaps by manipulating the quantum environment itself. It's the eternal cat and mouse game. New ways to hide, new ways to seek. Quantum computers will be needed to process the flood of data these systems generate. Secure, quantum encrypted communications will link sensors and shooters. The winner won't just build the first radar, they'll build the first quantum ecosystem. The stakes are enormous. The outcome will shape the balance of power for decades. The quantum arms race is underway. The world is watching. The future of stealth is uncertain, but the age of easy invisibility is ending. Quantum radar faces huge technical hurdles, but the physics is sound and progress is relentless. For now, stealth jets will keep flying, but their missions will evolve. They may become command centers, directing swarms of drones from a distance. As quantum tech spreads, even smaller nations could gain the power to see what was once hidden. The world could become more dangerous as transparency increases. Every advantage in war is temporary. Every shield invites a sharper spear. The F-22 was built to haunt old machines. Now, new machines are being born to see ghosts. The race to master quantum physics is on. The game of hide and seek is entering a new era. The sky's future will be shaped by those who adapt fastest. Invisibility is no longer guaranteed. The next move belongs to the seekers and the hiders who refuse to give up.